Hi, welcome to my video on extra problems number 4 pertaining to circles. What we have is a circle here, and as you can see, it looks like a bullseye. The circles are concentric, which means that the center of O for this circle is also the center of O for the large circle. So concentric circles are circles that have the same center. And it says that AB is 8 units long, and it says that BD is 15 units long, and it says that AB is 3 units from O, from the center. So 3 units means it's the perpendicular distance down here is 3. So AB is 3 units from the center. That's the perpendicular distance of 3. And we have to find the length of CD. So to find the length of CD, let's see. What we have in the small circle, we have OA and OB are radii here. So they're equal. And because that's the center of the large circle, that means OC. So we have OA is equal to OB in the small circle. So that's this, I'm going to mark small and put a dot like that, small circle. And in the large circle, I have OC is equal to OD. Being concentric, the radii are equal. So let's look at the small circle first, right here. Oh, look at this triangle in this circle. So this is 3 coming down here. AB is 8. Because that's perpendicular coming from the center, it bisects the chord at 4 and 4. And as a result of having two sides of a right triangle, I can say C squared is A squared plus B squared. That's the hypotenuse. And we'll call this radii of the small circle. So we have R squared is 3 squared plus 4 squared. So that's a 9, 16. So R squared is 25. Oh, R is equal to plus or minus square root of 25. So the radius is plus or minus 5. So we have the radius of the small circle. Again, that's the small circle. The radius is 5. So if that's 5, then OA is 5 because they're equal. That means that this is 20. So we have a small circle, and so this OC is equal to OB, and that's 20. So that means this must be 15 to make up the 20, because 5 plus 15 is 20. 5 and 15 is 20. This is the radius of the radii of the large circle, so it's 20. So we need to get the length of CD. So what we can do is that we can draw the small triangle, and we have O, an A, and a B. We have the large triangle, draw just a little bit larger, which is OCD. So what we have, it don't make any difference. We can say OB is 5, and we can say that's 8, and we can say OD is 20, and we got to find CD, so let's call that X. So what happens is that this angle at O here is a common angle. Oh, I forgot to mention the parallel lines. This line is parallel to this one. Because these lines are parallel to each other, that means that this angle at D is equal to this angle at B. Or also, this angle right here at A, this one, is equal to this one at C. So these angles at O are equal because they're common, and this angle right at B right here is equal to this angle at D. So we have similar triangles by what we call the AA similarity. That is, if you have two angles in one triangle congruent to two angles in another, the triangles are similar. As a result, we have a proportion. So 5 over 20 is equal to 8 over x proportionally. So this triangle, what we have is triangle OAB is similar to OCD. So this side over this side, so OB over OD equals AB over CD. And we can cross multiply. Now we get 5x is 160. So we divide by 5 and we get 5 into that is 32. So this is 32 in length, CD. So CD is 32. And it makes sense too if you want to look at it another way. If this is 5 and this is 20, this length is 4 times this. So 4 times 8 makes 32. Okay, let's have a look at another one. Again, the more problems you do, the better you get, the more you can think. 3 sides of a rectangle are tangent to a circle. The diagonal of the rectangle is 4 root 5 long. Find the exact area of the region outside the circle. So you got to draw your diagram. You got a circle. Okay. 3 sides of the rectangle are tangent to the circle. So tangent is 3 sides, is one right here. And this one is coming in here, tangent. And this one is tangent. So 3 sides of the rectangle are tangent to the circle. So there's tangent here, and tangent here. And that means the diagonal will come. So that means if this is the center of the circle, and because it's tangent, then from here to here is a right angle, from here to here. So this side has to be the same length as this side. So that, and this is a right angle here. This is a right angle here. And this is a rectangle, so that has to be a right angle, and that has to be a right angle. So the center is here. So the segment drawn from the center, O, is perpendicular to this tangent. So that's a right angle, that's a right angle. So this side is the same as this side. Opposite sides of a rectangle are equal. And let's see what we have. We have a diagonal is 4 root 5. So this diagonal going up through here is 4 root 5. So because this side is equal to this side, so if I draw a line through here, so if we make that x, this is x, and this is a tangent and a radius, so this distance here is x, this is x, this is x, and this is x. Because what happens, you have a right angle, and this is 4 root 5, so this side is x, this side is 2x, because they're tangent, x, 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 all the way around. So c squared equals a squared plus b squared. And notice this reason why all these are x's. Think of it. This is the center. This is the radius. This is the center. This is the radius. This is the center. This is the radius. So all of these are equal. So really what we have, this is a square. So x is here, x is here, x is here. This is x. So they're all x's. So that means that in this rectangle, we have the hypotenuse is 4 root 5 being squared, and this side is x, and this side is 2x. Again, just to make sure, this is the radius, this is the radius, this is the radius. So all these are equal. So this side is x, this side is 2x. So square it out, 16, 4 root 5 times 4 root 5 is 16 times 5, that's an 80. So that's an x squared. So 2x times 2x is 4x squared. So 80 is equal to 5x squared. So x squared divided by 5 will give you 80 divided by 5 is 16. So x is plus or minus the root of 16. X is plus or minus 4. So the length has to be a 4. So this is a 4. And this is an 8. Okay, and the radius is 4. So we want the area of the region outside the circle. So we want this area here, and this area of the rectangle, the area of the rectangle outside the circle. We want the exact area. So let's get the area of the rectangle. So the area of the rectangle is length times width. So the length is 8 times the width is 4. So that's 32. And a centimeter, so it's square centimeters. Now we want the area, and again, if you think about it, this is a diameter, so this is a semicircle. So the area of the sector, or you can say semicircle, either or, whatever you want, is central angle over 360 pi r squared. And because the arc is 180, a semicircle, 180 divided by 360 pi with the radius is 4 squared. 180 over 360 is a half, because a half a circle. So that's a 16 divided by 2, so that's 8 pi centimeters squared. 4 squared is 16, 2 into 16 is 8. And so the area outside of the rectangle is, the area outside is the area of the rectangle minus the area of the, you could say, sector or semicircle. So the rectangle is 32. And did I say 8? Yep, that's a 4 and a 4. So it was 5, 8, yeah. 32, so it's 32 minus 8 pi centimeters. So it's the rectangle minus the semicircle, and we have and that's square centimeters. So 32 minus 8 pi centimeters squared is the area outside. And again, a nice little question, but you had to draw your own question and figure out the diameter here, and this is the radius, etc., etc. So that's why I put X, and X, and X, etc., etc. And again, if you like my video, click the like button, click the subscribe button if you want to subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content in my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.